So when we talk about 3D modeling, there are basically two aspects. One is the aesthetics of the model, right? Just the general design. Does it look good? Is it appealing? And the other is the topology. So when we say topology, it's basically referring to the the surface characteristics of the model, basically the grid flow, what the wireframe looks like. So, for example, this wasn't necessarily my favorite show, but my kids watched it and got to do what the kids like. So, if we look at this model, right, you could make some arguments whether it's good looking or not, but um, you could see it's oh look at her nails not or some of her nails aren't painted. Anyway, you can see, it looks like the character looks pretty good. If we click on the model inspector here, I can look at the, where is it? Thought it was in here. Wireframe. Okay, I can look at the wireframe here. Um, Let me put that back. And then, oh, stupid thing. Okay, maybe it's only visible when that's open. That's annoying. But I can see the wireframe, and that's the topology, right? So when we talk about the topology, that's what we're talking about. Notice that this is all triangles. Technically, the computer can only see triangles, but um, when you usually put stuff into a game engine or like something you're viewing here for viewing purposes and you're not modeling on it, it will automatically translate and show the triangle. So, for example, if you look here, you can see these are quads. See how that's a quad, that's a quad, that's a quad. It just put this across because technically they are triangles. But when they modeled it, they did model it in quads. Okay. They're not like uneven triangles. So when we create our topology, what we're looking for, or what we're looking at, are the edge loops and rings. Basically, if you're familiar with drawing, when you do your shading, the idea is you're supposed to shade it going cross contour, meaning like your line should go around the figure to give the impression of it looking three-dimensional, to give it a sense of form, right? One of the elements of art. So if you look at this print from like the $1 bill here, you can see the lines going across, and it gives us a sense of depth. We want to do the same thing with our models. So we want our models to have, like if I look at the arm here, I want cuts to go across. I want these edge loops to go this way. And then I also want ones to go this way. So we end up with nice quads. Same thing with the fingers. You can see this is kind of even as well. So we end up with edge loops and rings. Ring just means like this is you can kind of, they're kind of the same thing. Um, what we're looking for over the entirety figure is a general grid flow. So I want the lines to support the form, meaning I want it to run across the contour of it so that that way it makes sense with the volume of the object. Like, I want to use a cylinder for where it's like here. I want to use kind of a cylinder kind of cutout for where it's like a cylinder, right? But then like right here, for example, you look at the buttocks, instead of having this go straight down, there's actually an edge loop that goes around. You can't see it well here, but there's an edge loop that goes up and around, right? Which helps support that the buttocks shape. Okay. You'll see around the elbow, I put an edge loop like this, which helps support that kind of bump on the elbow. Um, so you can see basically we try to have the edges go around the body in the same manner that the general like surface is. Okay, that's the grid flow. That's what we're looking for. Generally speaking, whether you're doing characters or you're doing objects, environments, you're always going to look for like just a good, clean grid flow. Um, Now, the other thing that we have to take into account when we do characters is deformation. So this is not going to be something that just animates like this, right? It's not like a character on a popsicle stick. He has to be able to bend and flex and twist and contort. So when we do that, we actually have to create geometry that supports it, meaning we'd have to put enough edges and geometry in like where the arms are going to bend in order to support the type of deformation that we are going to be producing. So depending on how it bends, you're going to put in different geometry. So typically what that means is on the knees, the elbows, fingers, wherever there's going to be like an elbow joint, you'll put in extra edge loops. So that way you have something for it to spread across so that it can expand. And then if you have stuff where it's going to go over a large region, so like a spine, right? It bends across the entirety of the mass or like a tail. you're going to just put those evenly all the way across so that way they can bend evenly all the way across. So depending on the type of motion that it's going to create, you need to support that with a proper amount of geometry as well as the grid flow itself, right? So there's even more topology concerns when we model characters. One of the things we also want to avoid are what we call stars and poles. Basically, the idea is you'll notice, like if you look at this section, see how there's 1, 2, 3, 4 edges going to a single vertice, right? You can see that's most of the time. However, you'll see there's parts where there's actually 5. So 1, 2, 3, 4, 5 right here, 1, 2, 3, 4, 5 here, and then 5 here. Whenever you have a grid flow, so you can see this is a grid, right? And it's going this direction / this direction, right? So it's just going this way and it's going this way. Whenever it changes direction or you have something coming out of another one, you're going to end up with poles. There's just no way around it. What you don't want to have happen is have a pole that has like 8 edges all going to the same vertice. It'll create like you'll see the surface will have like an incongruency, like there'll be like a physical bump there. Also, when it goes to move, it'll create weird like pinches. So this is okay. This is what you would typically see. And then so these are stars. Poles are kind of the same idea, but basically whenever you have a grid, a flow terminating, you're going to end up with 3, right? So you can see there's only 3 here. Again, this is fine, but you don't want to. If you end up with 2, yeah, that's a big no-no. If you only have 2 edges on a vertice, that means something's not right in the state of Denmark. So you can see where this loop, where this flow ends, you're gonna end up with a pole. Then it comes down here and then it ends. So whenever it terminates, you're gonna end up with those. But basically, you just try to limit those to only 5 edges and only 3 edges. You're shooting for 4 edges in all of them. Hopefully that makes sense.